Right. So in this lecture, we're going to look at the derivatives of a special group of functions. Okay. Now, I'm sure you're all familiar with these, and most of you hate them, I know, and some of you don't mind them, but I'm pretty sure nobody likes them at all. Okay. But we're going to change that today. Okay. This group is called the trigonometric functions. Okay. So your sine, cosine, tan, all of those. Okay. So we are going to try and find the derivatives of these functions, okay? And we're going to start appreciating their beauty and simplicity, okay? So let's get right into it, okay? Let's start with this graph we have here, okay? Now, the reason of having this graph is we're going to try and find the derivatives of sine and cosine of x, okay? So I have sine of x here in red, and I have cos of x here in blue. And here we have the derivative of sine of x, Here we have the derivative of sine of x in red, derivative of cos of x in blue, okay? So let's start by looking at the graph of sine of x and trying to get an intuition for what the derivative might be, okay? So we can start by looking at some points and seeing the derivative, the tangent, and hence what the derivative is, okay? So for example, right, at this point here, all right, the derivative, the tangent seems to be horizontal, okay? Therefore, the derivative must be 0, right? So if we plot the derivative function, it would pass through this point 0, okay? Pass through 0 when x is at this value, okay? Similarly here, okay, the tangent seems to be horizontal again, all right? And therefore, the derivative is again 0. And the derivative function at this x value would also pass through 0, okay? Very good. One more, right here, another 0. And again, it would go. Oh, sorry. I got confused myself with the function. Okay, now moving on. Let's look at this point here, when x is 0. We can see that the derivative is almost 1, okay? It looks similar to 1. And if the derivative function was to be plotted at x equals 0, it would go through 1, okay? We can do another point right around here, okay? And we can see that the derivative is around like -1, okay? Sort of like that, all right? And then if we had to plot the derivative function, it would go through -1, okay? So when we plot these, you can see the coincidence that whenever we plot these derivative function points, okay, they happen to coincide with the cosine function, okay? They happen to land on it, all right? And that is indeed the case, right? That whenever you try and find the derivative of sine of x, it is the cosine of x, okay? That is actually true. And you can't just see it from the points. You can even like see the trend, okay? Here, for example, the tangent is 1, okay? Then it gets less and less positive until it reaches 0. Then it starts getting negative until it's reached -1, okay? The tangent. Cos of x starts at 1 at x equals 0, okay? It gets less and less positive until it reaches 0. And then it gets negative until it reaches -1, okay? So the trend even does follow. So as a matter of fact, the derivative of sine of x is cos of x, okay? So we can now do the same thing we did with cos of x, okay? And try and find the derivative, okay? So let's start here. I'll use a different color to avoid any confusions. Let's try this color here, okay? So we have that, okay? Here, the tangent is horizontal. Therefore, derivative is 0. And if we plot it, it passes through 0 at this point, okay? So just from that, it may look like the tangent is, the derivative function may be sine x, okay? It might be the other way around, the opposite of what it was for sin x. Okay, so when we derive sin x, we got cos x. Maybe it's the other way around this time. So let's just keep looking. Here we have another horizontal tangent, and again, plot it, goes through 0, aligned with sin x. Okay, so it's starting to look like that might be the case. Okay, let's just do a few more points. We have this one here. Okay, we can see that when we graph this, or when we draw the tangent, the slope is actually 1, okay, or close to it. Okay, if that is the case, then when we plot it, it will be around here rather than on sin x. Okay, and similarly, here the tangent is -1, and it would, if we plot it, the derivative function would pass through -1 at that point. Okay, so it doesn't align with sin x, okay, entirely. Okay, in fact, it does exactly the opposite. Okay, so when sin x is 1, the derivative is -1. Okay, when sin x is -1, the derivative is 1. So it's kind of like flipped along the y-axis, or x-axis, sorry. So it might be the case that if we flip sine of x, we get the derivative function we are looking for. Okay, that could be a possibility. So luckily, I already have that here. Okay, and we are gonna look at that. Again, the function in blue is cos of x. Okay, and the function is red, is this time negative sine of x. Okay, now we already know that these points line up. Okay, so where the tangent is horizontal, this is 0. Where the tangent is horizontal, this is 0. Okay, but now when the tangent is -1, as it was here, negative sine of x is -1. Okay, so the point starts to align. Similarly here, tangent is 1. Okay, when you plot that, it happens to coincide. Okay, and now the same thing starts to happen. You can try and following the trend again. Okay, so for example here, okay, the derivative starts at 1. Okay, gets smaller and smaller and smaller until it reaches 0 here, and then it becomes smaller and smaller and smaller till it reaches -1. That's what happens with negative sine x. Okay, it starts at 1, gets smaller and smaller and smaller till it reaches 0, gets smaller and smaller and smaller till it reaches -1. Okay, so both of them follow the trend, and that is in fact what we have thought of here is in fact true, that the derivative of cos of x is negative sine of x. Okay, and there we have it. Okay, let me just write that with a different color. There we have it. The derivatives of sine of x and cos of x. Okay, now this again is not a formal proof, and the formal proof is beyond the scope of mathematical methods. Okay, so we are not going to do that here, but that is indeed the case. And because we are not doing a proof, if for some of you the idea may not still be believable, but you can search up the proof if you want. If you want me to, I can show you the proof, okay, separately. But I won't be doing it as a part of the course. I can show it to you separately. But regardless, what we do from this point onward is, as per usual, we're going to do a lot of practice questions, okay? We're going to do a lot of practice so that we get comfortable with the idea of the derivatives being sine and cosine and they being linked. That may be seeming a bit unusual, a bit weird, so you can't sometimes put your finger on it, but doing the practice questions, it's what's going to clear out all of those clouds, and you're going to be feeling a lot better as we keep going, okay?